All right, welcome back for the next tutorial for ECED 3403. Today we're going to be going over how to set up your first project in Visual Studio Code and navigate through that using Visual Studio Code and the command line. And there are some other extensions and a couple other topics that we'll touch on as we go through. So without further ado, let's get started. The first thing that we're going to do is we're going to boot up the terminal. So I'll just exit this one. And in order to get into that, remember we can click down on the icon there or press Control-Alt-T. I prefer to use the keyboard, so that's my go-to. First thing we're going to do is change directory to /media/sf_tutorial where I created the shared folder in the previous video. And we're going to make a directory, so mkdir, and then we're going to call that directory demo. Then from the terminal, we're actually going to launch Visual Studio Code. So we can type code demo, and that will launch Visual Studio Code and open the folder that we passed in as an argument. In this case, it was demo. So you can see here that demo is an empty folder. So what I'm going to do now is just close this out and show you how to open up terminal the clicky way, which is not my preferred method. So I will remove demo. So remember, when you remove a directory, you have to pass in the -r flag, and it would help if you can type correctly. So now I'll close out the terminal, open up Visual Studio Code, and you're going to be brought up to this welcome screen here first off. So we can click open folder here, or if this for some reason doesn't pop up, you can go to file and then open folder. So navigate to this spot, so it might actually show up as the home directory for you by default. So this mounted drive here is where you want to click, and that'll take you right in there. And you want to create a new directory for your first project. So again, I'm going to call this demo. And now notice up here that it has brought us into the demo folder. We can just click OK. And we are right back to where we were when we did that from the terminal. So notice that the terminal was much quicker, less clicking around, which is why I like it. I highly recommend familiarizing yourself with the Bash terminal. So for those of you not familiar with Visual Studio Code, it actually has a built-in terminal, which you can run by either clicking terminal and then new terminal, or you can click Control and then the backtick. So the backtick is right above the tab on your keyboard, and it's also associated with the tilde if you hit Shift. So the tilde is this character here. Now you can see we're in a terminal, and it acts just as the Bash terminal does. So we can do an ls. We can see there's nothing in there. We can do an ls-al. We can see that we have our parent directory, which is the ... and we have our current directory, which is the dot. So remember that from the first video. So now we can go up to View, and we can click the command palette, and that will bring up a little search window here. Or we can do that with Control-Shift-P. So learning your shortcuts is definitely a great way to go. We're going to type in make to create our first project. I must have had a typo there. So there we go. So we want to do make, and it may or may not be the first option, but you're going to come down to C++ make init project. So we're going to do that there. And then we're going to choose a C project or a C++ project. For this demo, we're going to choose a C project. So just hit enter on that. And notice it now brings up a makefile. In addition, on the left-hand side here, we can see there's two new directories. There's the object directory and the source directory. And we can also see down in the terminal. So again, if I use the control backtick, my cursor moves to the terminal, and I can do an ls. And you can see that we have the object directory and the source directory there, as well as the makefile executable. So remember, if we pass in the dash capital F flag, we can see those modifiers at the end there, the star and the /. Because this is an automated program and it doesn't quite configure things correctly, we need to make some modifications to the makefile. So what we're going to do, the first thing we're going to do, and this goes for every project, is we're going to add some LD flags. So these are the linker flags. And the first one we're going to add is we're going to do dash capital I, and then we're going to do $, paren, increment directory, or sorry, include directory. And that line is done. Next thing we're going to do is come down to line 15, and we're now going to type include directory again. So now it should be able to use tab completion. You're going to say equals, then you're going to do $, paren, source directory / include. So the reason we do that is because we want the include directory. So we can come down to the terminal and we can say ls source. So that's giving the ls command an argument, and that will show us what is in the source directory. So it's doing a listing on the source directory instead of the current directory. And we can see inside the source directory, there is the include directory. So that's why we want to make the include directory as this path here. Then we're going to go down to line 41, and we're going to add to the end of this, we're going to do $LD flags, and same with the line 48, so LD flags. And then lastly, you're going to come back up to line 11, and you're going to change the app name to whatever you want your app to be called. You can call it assignment 1, you can call it Bob's project, it doesn't matter, but just make sure that there are no spaces in your name. If you put spaces in there, things won't work correctly. So make sure it's all one word. You can use capitals and lowercase as you see fit, but just make sure it's all together without any spaces. So we can do hello world, and then we want to make sure that we save this. So anytime that a file is unsaved in Visual Studio Code, you're going to see this white dot there, and when I click Control S, you're going to see that disappear and turn back into an X. So we have now modified our makefile, and make is just a program that will execute the compiler command for you so that you don't have to remember everything to type in. As you can see, the file gets pretty complicated and you don't need to remember all of that stuff. So now we're going to add a new file, and we can call this whatever we want. You can call it main.c, you can call it helloworld.c. I'm going to call mine helloworld.c, but we want to add that in the source directory. So again, I'm going to use my terminal. So control backtick takes me to the terminal, and I want to cd into the source directory and then touch hello eced.c. So now you can see, as soon as I did that, the file shows up in our File Explorer, as well as if we do an ls, we can see that in there as well. So now I want to open that, so control backtick to get out of the terminal and open that up. So I'm just going to type the hello world program in here, and then I will be right back. Alright, so I've typed in the hello world program. I'm sure all of you have seen this before. Very simple. Notice that I haven't saved it yet. So I'm going to do that, and immediately you will notice the brace on line 3, so the very last character there, is going to move down onto line 4. So we can do that. And that is actually because we have an extension installed for you called Clang Format. So what Clang Format does is it will automatically format your files to meet a certain standard as you save them. This prevents the need for you to go through and manually format them all. There are a lot of different formatters out there. You can mess around with the settings of this if you want. We have the Google default set up. So when you save things, it will be saved to a Google format standard. You can change this to whatever you want. You can put in custom settings if you want. That is something you can learn on your own time. We also have a couple other extensions. We have CMake and CMake tools. I'm not going to go into what those are. If you want to use them, they are available for you, but they are not required for this course. We have the C and C++ Makefile project, so that's what we already use to generate our Makefile. And then we also have C and C++ IntelliSense, which is the pop-ups that you saw when I was writing the Makefile. So it was doing an auto completion for me. If you don't have that installed, it doesn't work for C++ and C. So that's a very, very handy plugin for you guys to use. So now that we've written our Hello World program and saved it, we can open up the terminal again, and we can do a clear just to get rid of some of the clutter here, and then we're going to type in our make command. So it's a really, really simple command. All you do is literally type make, and don't make typos like I do. So then you hit enter, and it says no targets are specified. So notice the directory that we're in. So if we look here on the command line, it says we are user, this is our machine, and then it shows the directory that we're in. So we're in /media/sf tutorial/demo/source. So we actually don't have the Makefile in this directory. So that's why we got this error. No target specified and no Makefile found. So that's our clue. We have a no Makefile found error. So we need to get back to the directory that the Makefile is in. So we're going to do a cd // The slash isn't necessary, but you can put it if you want. So cd .. will take you to the parent directory. And now you notice our path has changed to /media/sf tutorial/demo. And if we do an ls, we can now see that Makefile in there. So now we can type make, and again without typos, and you can see the commands that it executed for us. So it said gcc-standard equals C++11, or C11, sorry, -w all, so that means that all warnings are turned on. -o, so that's creating our object files. So hello eced.o, and that's going to be put into the object folder. So if we do an ls obj, we can see that hello eced.o was put in there. And then -c, so those are our C files, and they're coming from source hello eced.c, and then our LD library flag, so we can see that is -i source/include. The next thing that we see is another GCC command, another standard, more errors. Our output is going to be the Hello World program, and we have the hello eced.o there as our input, and again the linker flags. So now if we do an ls on our demo directory, we can see that we have two new files. We have the hello world file, and we also have hello eced.d. So the .d file is a dependency file that's created by make. Because it's green, you know it's executable, but if you try to execute it, it won't do anything for you. It's used strictly by make. But we can execute the hello world program. So to do that in Linux, we're going to type // and then we're going to start typing hello world, and we can use tab completion. So notice that it stopped me after the hello because the first 5 letters of hello ECD and hello world are all hello, and they're all lowercase. So it completed up until it couldn't complete anymore without any more user input. So then I typed a capital W and then hit tab again, and it finished it off for me. And now when we run this, it prints out what we expect it to print out. So let's talk a little bit about this // here. The / is the current directory. So in order for Linux to execute something, it needs to be told the entire directory of the executable. So the entire directory path, sorry, of the executable. So we can execute it using // which means current directory, or we can actually type out the entire path to that executable and get the same result. So I can type /media /sf_tutorial/demo hello world and run that again, and we get the exact same result. It's just much quicker to type / hello world, and we are done. So I'll clear off the screen here with the clear command. And the next thing I want to talk to you about is the make clean command. So sometimes when things get rebuilt, not all your files get touched when you're doing a full rebuild of a multi-file project, and you can actually do a make clean. So what make clean does is it removes all the dependency files and all the executables built by make. So we do make clean, and you can see it executed the command remove, rm, and it removed the object file, and it removed the dependency file, and it removed our executable. So we can do an ls, we see that those aren't there anymore, and ls obj, and that's not there anymore either. So I'll clear off the screen again. Next, what we're going to do is we're going to create a multi-file project. So I will create an include file, so a header file, which is a .h file, and then I'll also add a second source file. So I want to cd into my source directory, and then I want to touch to create a file, and I want to do include, and then I'll just call it a really simple header.h, and I will touch a library.c file. So now if I do an ls, we can see that library.c is added and an ls include and header.h is in there. So I will go edit those files and be right back and show you what they look like. Okay, so we're back. You can see that I've changed the main program just a little bit. I've changed the first line, so instead of including stdio.h, I'm including header.h now. And instead of doing a printf on line 5, I'm just calling the function output. And then if we look in header.h, so I just used control tab to cycle through my tabs there, we can see that there is a function template on line 4 that gives a void function output. And then we can see in library.c that the definition of that function is there, and it uses printf, just like we saw before. And on line 1, that's where we have stdio.h. So I'm actually going to change the print function just to prove that we're doing something different and I'm not using any sort of trickery, although I'm sure you can believe me anyway. So I'm going to add hello ECED3403 from another file, or let's say from library.c, and I will save that. So then we're going to control backtick into our terminal. So you can see there that I actually have some other commands in the terminal. So I used the terminal to open up those new tabs. So I passed in the -r flag to Visual Studio Code, which means reuse the same window. And that is what created the tabs for me. So I opened the library.c file and the header.h file. So now you can see I'm in the source directory, so I need to cd up into the demo directory and type make, and you can see the same sort of commands there again. This time we have an extra one because we do have an extra file to build. So now we can do an ls, and we can see now we also have an additional dependency file. And if we do an ls on the obj, we have an additional .o file as well. So those are object files. And we also have our normal executable hello world. So we can do /hello world, and we can see it says hello ECED 3403 from library.c. That's all I have for you guys today, and I will look forward to seeing you in the next video, or I guess you can look forward to seeing me. I stare at a computer screen while I make these, so talk to you guys later.